All right, now there's a few problems in your homework that are have objects connected together. Okay, so it could be something pushing on something else, or like this one, something pulling on something else. And in this particular problem, we've got a block B and it's pulling block A. All right, and it's got a certain mass. Okay, mass of B. All right, we are in English units, pounds here, so this is going to be 8 pounds over 32.2. All right, feet per second squared. And block A, MA, is 10 pounds. And I'm just going to put over G right there like that, okay? And let's go ahead and look at what forces are acting on them. So on B, we're going to have the weight. So we've got MBG, and we've got some tension here. And then we've got that same tension over here because we're assuming it's an ideal pulley. Weight, MAG, and a normal force here. And so those are going to be equal to each other. And then we've got our friction here. All right. Now it's sliding, so we're going to have kinetic friction, but you'll notice it doesn't tell us what that is. And the reason it doesn't tell us what it is because it says determine the tension and the coefficient for the kinetic friction. All right. So that's what we're looking for there. Okay. Now, the way the system is set up, as B pulls on A, okay, the system accelerates. So really MBG, the weight of block B, is the driver for the whole system. So that weight is accelerating both blocks and the friction is resisting all of that. All right. So we could zoom out and we could think about it that way. And often that's the way I like to do these kinds of problems, but I'm going to do it differently this time for you. So you can see a little bit more of a traditional approach to how you do these things. And so what we'll do is we're going to look at the impulse for each block. Okay. What's happening with the impulse for A, what's happening with the impulse for B. Okay. All right. So let's start with A. Okay. I'm going to have a fun new color here. All right. So with boy, if I had a nickel every time I did that. All right, so with A, we're going to be looking at delta P for A. It's going to be my integral F dt. And I'm just going to put some A on here, meaning that that's the sum of all the forces acting on A. Okay, that's what I mean to say there. So we're going to have here PA final minus PA initial, and all the forces here are constant. We don't have any functions of time like we did in the previous one with the little motor. So that means when I do my integral, it just turns into an FA delta T like this. So my forces, I'm going to have tension minus the friction acting on A, and there's our delta T. Okay, now our delta T, it tells us up here it's 5 seconds. Okay, and we are starting from rest. Okay, here, and so this initial term, it goes to 0. All right, so PA then becomes MA onto V final, which will be the same for both blocks, and that's 1 foot per second squared. All right, and let's keep going with this stuff here. So I've got T minus mu K times the normal force, which we already determined was mg, delta T. All right, so let's look at this one real quick. Again, what's the thing we're hunting for? We're hunting for tension. We're hunting for mu K. All right. And so if we look in this particular equation, all right, we know mass, velocity, mass G. Okay, so, and those are the things we're hunting for, just like that. Okay, that should be a little A right there. two unknowns, one equation. That ain't gonna work. Okay, so we need some more relationships in here. All right, which is fine because we have a whole nother block to look at. All right, so let's look at block B. All right, we'll do the same sort of thing. We're going to say delta PB is the integral of FB dt. All our forces are constant again, so that just becomes the total forces acting on it, like so. PB, same sort of thing. It's starting from rest. And so my delta PB actually is going to turn into MA. Not MA. How about MB? MB times V final. Okay, and once again, we know that's there. Okay, and for FB, this time we've got our, we want to go in the direction of our velocity because we called that velocity term is positive and that happens to be down. So I want to say this is MBG minus the tension. Okay. Otherwise, I'm going to end up with a weird negative sign and I have to work it out in there somehow. Okay, and that's going to be problematic. Okay, so now what do I know? We know this, we know this, we know that term, we know that term. The only thing we don't know is our delta t. Ah, sweet. Okay, so mission accomplished there. Now I have two equations and I've got two unknowns. So all I would need to do then at that point is to plug in my numbers, solve for t and solve for delta k. Obviously find t first and then plug that in over here. Okay. And so, I mean, that's pretty easy algebra. That's 8th grade level algebra. You guys can do that. So I'll leave that to you. Okay. Anyway, that's it for this particular series.